Hi guys, this is O-level chemistry, paper 12, June 2021, question 11. The relative formula masses of four compounds are given. A student has a 1 gram sample of each compound. Which sample contains the highest number of moles of oxygen atoms? So, if we need to find out which sample contains the highest number of moles of oxygen atoms. The moles of oxygen atoms. So we need to find out how many oxygen atoms are present in that compound. So for Al2O3, we have three oxygen atoms. For CuO, we have one oxygen atom. For H2SO4, we have four oxygen atoms. And for HNO3, we have three oxygen atoms. So now, in order to find out number of moles, first we need to find out moles of the given compound. So it says 1 gram of the compound. So for A, we have 1 gram and the MR is 102. So 1 upon 102 gives us a value of 0.0098. Similarly, for B, we have 1 over 80. This gives us a value of 0. Double, no, 0.1, 0.0125. 0.0125. For C, we have 1 over 98, which gives us a value of 0.0102. And for D, we have a value of 1 over 63, which gives us a mole value of 0.0159. Now, the next step is to multiply each of these with the number of moles of oxygen, the molar ratio of oxygen. So, for the first case, it is multiplied by 3. For the second one, it is multiplied by 1. For the third one, it is multiplied by 4. And for the fourth one, it is multiplied by 3. So, for the first one, we end up with moles of oxygen as 0.0294. For the second one, the moles of oxygen remains 0.0125. For the third one, the moles of oxygen become 0.0408. And for the last one, we have a value for the moles of oxygen as 0.0477. And this asks us which sample contains the highest number of moles. So the highest number of moles is 0.0477. So this makes option D the correct option for this question. Question 12. 10 cm cube of propane is burnt in 70 cm cube of oxygen in a closed container. What is the total volume of gas present after the reaction? So the molar ratio of propane to oxygen is 1 is to 5. That means 1 mole of propane would require 5 moles of oxygen, which also means that if 10 cm cube of propane are present, it would need 50 cm cube of oxygen to react, and the amount of oxygen present is 70 cm cube. So if we minus 50 from 70, we are left with 20 cm cube of oxygen in excess. And now the molar ratio of propane to carbon dioxide is 1 is to 3, which would result in the moles of CO2 being produced as 3 into 10, giving us 30 cm cube of carbon dioxide being formed. So, in total, we are left with 30 cm cube of carbon dioxide and 20 cm cube of remaining oxygen as the gaseous mixture at the end of the reaction, making option B the correct option for this question. Question 13. When a mixture of sodium chloride and sodium hydrogen carbonate is heated, the reaction shown takes place. Okay. Sodium chloride is unchanged on heating. When 6 grams of the mixture is heated, the loss in mass is 1.5 grams. Okay. Loss in mass. What is the percentage by mass of sodium hydrogen carbonate in the mixture? So, in order to get this, first we need to find out how many moles of gas has been lost, because here CO2 and H2O are both gases. So the loss in mass is 1.5 grams. So it would be 1.5 divided by, now we would need the sum total of the MR of these two gases. So for carbon dioxide, it is 44, and for water, it is 18. So 44 plus 18 gives us a value of 62. So 1.5 divided by 62 gives us a value of 0.0242 moles. So the total moles of gas that has been lost is 0.0242. And according to the molar ratio, the mass, not the mass, the moles of NaHCO3 will be twice the number of moles lost, 2 into 0.0242, which will give us 0.0484 moles of NaHCO3 being present. Now, out of the 6 grams, we have 0.0484 moles of NaHCO3, and the remaining mass, 6 minus 1.5 will give us 4.5 grams of NaHCO3. But now they're asking us for the percentage by mass of sodium hydrogen carbonate in the mixture. We don't know whether this mixture is pure or not. So what we are going to do is, first thing we are going to find out using these moles, the mass of NaHCO3 that is actually present, because theoretically the mass of NaHCO3 that should be present is 4.5 grams. So what we do is mass equals moles into MR. So moles we calculated as 0.0484, and the MR of sodium hydrogen carbonate when calculated comes to 84. So we multiply these two values and we obtain a mass of 4.0656 grams for NaHCO3. That means out of the remaining 4.5 grams, only this much is NaHCO3. So the rest must be further impurities. So now, in order to calculate the percentage by mass, what we would do is the mass that we obtained using moles, 4.0656 divided by the total mass of the solid that we had, 6, and then into 100. This gives us a value of 68%. And the value that is correct is present in option C, making option C the correct option for this question. Question 14. Molten sodium chloride is electrolyzed. Which change occurs at the cathode? Cathode is where reduction takes place. Sodium ions are oxidized? No, sodium ions do not get oxidized. Sodium ions accept electrons and are reduced to sodium metal, whereas chloride ions give off electrons and form chlorine gas at the anode. These are the electrode reactions that take place. So sodium ions are oxidized? No, they are reduced. Sodium ions are reduced? Yes. Chloride ions are oxidized? Yes, they are oxidized, but not at the cathode. And chloride ions are reduced? No, they do not undergo reduction. So this makes option B the correct option for this question. Question 15. Which positive ions are present in aqueous copper 2 sulfate? Copper 2 ions only? What are the other options? Copper 2 ions and hydrogen ions. Yes, because this is an aqueous solution, so water will contain hydrogen ions as well. So copper 2 ions only is not correct. Copper 2 ions along with hydrogen ions is correct. Sulfate ions only. Sulfate ions are negative ions, not positive ions. And sulfate ions and hydroxide ions. Yes, sulfate and hydroxide would have been the answer if they would have asked for the negative ions present. But since they've asked for the positive ions present, the correct option for this question is option B. Question 16. Natural gas is used as a source of energy. What is the main compound in natural gas? It's methane, CH4. Natural gas contains methane. It is also known as biogas. Okay, methane because it is produced from fermentation of different and combustion of different waste organic waste. What is the main compound in natural gas? Ethane? No. Ethene? No. Methane? Yes. Methanol? No. So the correct option for this question is option C. Question 17. Ethanol is produced by the fermentation of glucose from sugarcane. In some countries, ethanol is used as a fuel. Yes, like Brazil. Which statements are correct? One, sugarcane is a non-renewable resource. No, it is not finite. We can regrow it. It is a renewable resource. So statement one is incorrect. Statement two, when sugarcane is grown, it removes carbon dioxide from the atmosphere. Yes, because photosynthesis takes place in which carbon dioxide combines with water to produce glucose, which is C6H12O6, and it produces oxygen gas. So in this, we have removal of carbon dioxide taking place. So this makes option 2 correct. So if option 2 is the only correct option, then the correct answer for this question is option B. Question 18. Aqueous sodium thiosulfate reacts with hydrochloric acid. The rate of reaction increases if the concentration of both reactants is increased. Okay. Nitrogen gas reacts with hydrogen gas. The rate of reaction increases if the pressure in the reaction vessel is increased. Okay. Which row correctly explains why the given change increases the rate of reaction? So for aqueous sodium thiosulfate and hydrochloric acid, A says higher frequency of collision between the particles. Yes, because if the concentration is increased, that means the concentration of the reactants is increased. There are greater number of reactant particles or molecules present. So when they collide with each other, the frequency of collision would become greater. So this is the correct explanation. And for nitrogen and hydrogen, higher frequency of collision between particles. Yes, the greater the pressure, the greater the frequency of collisions. So if the pressure is increased, nitrogen and hydrogen will collide to form ammonia. Okay, so both are correct for A. Let's look at the other options. For thiosulfate and hydrochloric acid, we have got the same reasoning as A. So this reasoning is correct. But for nitrogen hydrogen, it says the activation energy is decreased. Pressure has no effect on the value of activation energy. So that makes this wrong. In the case of C, we have the activation energy is decreased for sodium thiosulfate and hydrochloric acid. Changes in concentration has no effect on the activation energy. And for nitrogen and hydrogen, the explanation is correct. And for option D, both the explanations have a change in activation energy mentioned. Activation energy does not change with changes in concentration or changes in pressure. Thus, option A is the correct option for this question. Question 19. Magnesium reacts with dilute sulfuric acid and the reaction is shown. Two experiments are carried out at 25 degrees Celsius. Experiment 1 is 24 grams of powdered magnesium is reacted with 100 cm cube of 1 mole per dm cube dilute 1 mole per dm cube sulfuric acid, and in experiment 2 the same mass of powdered magnesium is reacted with 50 cm cube of 2 mole per dm cube sulfuric acid. Okay, so now the total number of moles in both the cases would be the same because when we have 100 cm cube, the concentration is 1. When we have 50 cm cube, the concentration is 2. So in order to find out the moles, 50 into 2 would give us the number of moles divided by 1000, which would be the same as 100 into 1 divided by 1000 in the case of experiment 1. So the number of moles are the same in both the experiments, but the concentration in experiment 2 is greater than the concentration in experiment 1, which would result in the gas being produced, which is hydrogen gas being produced more quickly. Quantity of the gas in both experiments would remain the same, but the quantity of gas produced over time would be greater for experiment 2 than for experiment 1 because there is a greater amount of H positive ions in a lesser volume of solution present. So in option A, the dotted line representing experiment 2 shows a greater volume of hydrogen over time being produced, but the total volume remaining the same. So option A is the correct option. In option B, the dotted line, which is experiment 2, shows a decrease in the rate of production of hydrogen, but the total volume remains the same. But the decrease makes this option incorrect. Options C and D are both wrong because they are showing a lower volume of hydrogen gas being produced in experiment 2, which is not the case. So as a result, option A is the correct option for this question. Question 20. Solution X is colorless. A few drops of aqueous potassium iodide solution are added to a sample of X and no change is seen. Okay. Solution Y is colorless. A few drops of aqueous acidified potassium manganate 7 solution added to sample Y. The color of potassium manganate disappears. That means whatever is present in solution Y has been oxidized. Whereas in solution X, when aqueous potassium iodide is present and no change is seen, that means nothing in that has been reduced. So in solution X, an oxidizing agent is not present. In solution Y, a reducing agent is present. So absence of oxidizing agent and presence of reducing agent. This is the conclusion drawn from these statements. Now, the question, what can we deduce about X and Y from these two observations? X and Y are both reducing agents? No. Y is, X is not. X is an oxidizing agent and Y is not a reducing agent. Again, Y is a reducing agent and we don't know about X. X is not an oxidizing agent or a reducing agent. At least it is not an oxidizing agent as given by the test conducted. C, X is not a reducing agent. We have not tested for that. And Y is an oxidizing agent. We have tested for that and Y is a reducing agent, not an oxidizing agent. D, X is not an oxidizing agent? Yes. We have confirmed that it is not an oxidizing agent. And Y is a reducing agent? Yes. We have confirmed that Y is a reducing agent. So this makes option D the correct option for this question.